In our next module, we're going to begin talking about the Application Policy Infrastructure Controller, or the ACI APIC. So for our agenda, we'll talk about and do an introduction for the APIC, an overview of what the APIC is, how to install the APIC, and the web user interface. Of course, we'll be taking a lot more in-depth look at the web interface in our hands-on demo, and all of the demonstrations, except for the RESTful API. Even then, we'll be taking a look at the web user interface. It's very, very handy. However, we're just going to take a look at a brief overview of it here and kind of get a look and feel and know our way around. So, an introduction to the APIC. We've already talked about that the common goal of ACI is to have a common operations as well as policy framework. So whether you're a cloud admin, an application admin, a security administrator, or even a network admin, we have the ability to have a single common pool of resources tied together and administered from a single central controller, or really cluster of controllers. And that is the APIC. So what is the APIC? Well, it's the policy controller. However, it is not in the control plane, nor is it in the data plane or data path. So this is very important and a large distinction from, let's say, an OpenFlow controller, which may not be in the data path, but from a control plane perspective is still very much imperatively telling every single device what to do. And kind of one of the ways I like to enumerate or help explain imperative control, like OpenFlow, versus declarative control, such as maybe a Puppet model or a Chef model or Cisco ACI, would be asking one of you in my class, although this is not a live class, to go get me a cup of coffee. So I might say, John, please stand up, push your chair back, turn right, take 3 steps, turn right, take 15 steps, turn left, pull the door, and I might walk you through every single step of how to get me a cup of coffee. Whereas I could just declare my intentions. John, could you go get me a cup of coffee, please? Or really, that's an interrogative. So a declaration would be more like, John, get me a cup of coffee. All right, but the idea is declaring your intentions versus imperatively stating in an iterative fashion every single step along the way. Okay, so Cisco ACI is a declarative model and therefore is not in the control plane. Okay, it declares the policy to the fabric, and the fabric takes care of all of the distributed control plane functions that we've come to know and love, or at least understand very well at an expert level in depth over the years. Okay, with standard networking protocols such as ISIS or routing or equal cost multipath, with 5-tuple static hash buckets, with our port channels, and again our hash buckets for different port channels, for VPC, for OSPF, for BGP, all of these things that we know and hopefully love. Depends, I guess, on who you are watching this. They're still very much there making the decisions from a host by host or node by node perspective. Okay? And in terms of policy control, that's where the leaf engines, and really to some large degree the spine engines, play a role as well. And we'll be taking a look at their functions well beyond standard NXOS. So the APIC is a highly redundant cluster of 3 servers, and it can scale up to 31 in the future. So as an overview of the APIC, we have different functionalities. So first of all, everything starts with the API. So really everything is centered around the API, whether and this is very similar to, in fact, the same team created it. If you know anything about the Cisco UCS, Unified Computing System, specifically the B series, or at least the UCS Manager and the Fabric Interconnects, everything you do, whether you run command line scope commands, whether you run your Java or soon to be HTML5 web interface, or whether you just make direct API calls, both the Java interface or HTML5, the command line, those both make calls to the API, or whether you're just making straight direct API calls. The same thing is true with Cisco ACI. So when you configure from the web user interface, all HTML5 driven, whether you configure from enhancements such as something called the ACI toolkit, which does have a version of a command line. Everything that you do is API driven. So those all interface with the API. The API then interfaces with the database or the configuration files, and it makes the changes. So everything starts with that management API on the management console. Then we have 4 main breakdown framework subcomponents: the policy, the topology, the observer function, and the boot function. So the policy obviously defines policy, who consumes the policy, who can see who and where, and a registry of all the endpoints. The topology takes a look at a state and health in a condensed single form rather than node by node. Takes a look at the physical topology as well as the logical overlays. The observer module we'll take a look more at has statistics, faults and alerts, state information, health, which is a very important thing for application developers, and really will become so for network admins as you learn to really know and love this health score, and then logs and history. And then from the boot function, we have DHCP server, which is the APIC, serving IP addresses, and we'll talk about to whom, not to the endpoints, but to the fabric, leaf, and spine switches, as well as maintaining all the fabric node or switch images, as well as the APIC image. So the observer functionality, we have statistics, link utilization, unicast, multicast, packet drops, errors, things like this. We have health scores. We have health score for the entire fabric, for our spines, for our leafs, all together, one at a time, for our tenants, for our individual paths, even for our applications, and even for our endpoint groups. We have faults and events. And we have logs, forensics, diagnostics, all sorts of things that we'll talk a lot more about in our troubleshooting section. These all feed into the observer model. Now, ACI was really built around a fundamental concept of multi-tenancy. So at the very top, we have our universe level, or root if you want. We call it uni. And then we have individual tenants, such as here we have an example tenant Coke and tenant Pepsi with their one or probably multiple application profiles, EPGs, one or multiple VRFs, bridge domains, subnets, things like that. We also have the entire fabric by switch, by line card, by port. So all of this is under the universe level. And we'll talk about a few different tenants that we have, such as there are some built-in ones that we'll talk about a little bit later. We do have the ability to have local database of users as well as external AAA. So we can use TACACS, Radius, or LDAP for authentication and authorization. And we, of course, have RBAC, so role-based access control, in order to control and manage all read and write, read-only functions for all of the different managed objects, and to enforce fabric admin or per tenant admin separation. So the APIC controller I mentioned before is attached in band. We do have a separate out-of-band management network for each of the leaf switches and spines, so really we'll call those the nodes in the fabric, as well as for the APICs. But in terms of how the APIC communicates, talks to, and controls the fabric switches, it's all in band. So for every C220 server, it has a Cisco VIC 1280 card that is attached in band. Its 10 gig uplink interface is attached to a pair of 10 gig leaf switches. So it is actually important. I had one customer didn't know really any better when they did their ordering, and I wasn't there. I kind of came in as professional services later to help them stand up their fabric and configure it for the first time. But they didn't order any 10 gig fiber leaf switches, so all they had was all copper switches, right? Because that's what they were planning on using, was the TX models for connecting to everything. for some 1 gig, plenty of 10 gig, but you do have to have at least one pair of 10 gig SFP fiber, PX model leaf switches for the APICs to attach to. They cannot attach to spine switches, even if you have the 9336. Again, it's a 40 gig port only, but even if it had 10 gig ports, which it doesn't, you cannot connect to that. So you cannot connect anything to a spine switch except for a leaf. And a leaf, you can only connect either to a spine or to a host, which could be an APIC. So the ACI fabric supports discovery of the switches through LLDP using ACI-specific TLVs or type length values, and supports the booting of all the switches, inventory and system maintenance for firmware and other things through the APIC. So the fabric discovery and IP addressing is all done through the APIC, the firmware image management, as well as topology validation through the wiring diagram and system checks using that MCP miscabling protocol that we talked about. Now, all the leaf switches, and we'll actually go through this much more in depth, actually get their IP addresses from the APIC as the DHCP server. None of the other hosts attached to leafs can use the APIC as a DHCP server. And all of the leaf switches use loopback IP or loopback interfaces. Everyone will have a loopback 0. That is going to be its primary unicast unique VTEP, as well as the IP address that the APIC controls it through. So even if we configure out-of-band management 0 access for every leaf and spine switch and APIC, the APIC will still talk to the leaf and spine switches through the infrastructure VLAN, which we'll talk about, on that loopback 0 IP address, which was really handed out through DHCP from the APIC itself, the APIC cluster. Okay? And that loopback 0 is also what's responsible for IP unnumbered for all the ISIS. So it's actually impossible, as long as you connect to the right physical ports, it's actually impossible to miscable your fabric and not have it work. It's possible to miscable it, but as long as you use one of the 6 or 12 with the M6 or M12 uplink ports on a leaf to any one of the spine supported ports on either a modular or 9336 PQ baby spine, then the fabric will come up. It doesn't matter which interface you attach to which interface, given the criteria I just said, as long as you stay within that, it will come up. And the reason is we don't have, we do have point-to-point interfaces, but they don't have IP addresses directly on them. They're all using the, I don't remember the exact RFC right off the top of my head, but there is an RFC labeling Dijkstra algorithm like ISIS and OSPF protocols to use IP unnumbered. So that's what the fabric is using. So I tend to be a bit anally retentive and like, for instance, what would be E2.1 in this case, depending on whatever your first, M6 or M12 gem module port is, to connect to a particular, maybe first port on the first spine, and the second port on the first leaf to connect to the first port on spine 2, the third port on leaf 1 to connect to the first port on spine 3, etc. The first port on leaf 2 to connect to the second port on spine 1, 2, 3, 4, respectively. I tend to like that. Many of you will probably cable with that in mind, but even if you didn't, it would be perfectly fine. So talking about the cluster of 3 nodes, we have this function or really feature that many modern databases use, and I'm not going to go too deep into it, but it's called sharding. And all of our framework or functions, policy, topology, observer, and boot, are evenly distributed through shards. Now, it's not just one shard for policy, one shard for topology. It could actually be multiple shards, especially as we have more than 3 nodes in the future. And so think of sharding like hashing. For network engineers, we're more familiar with hashing algorithms. So think of it like we're breaking it up into small slices or chunks of data and hashing it out to the different nodes in the APIC cluster. And especially as we have more than 3 in the future, let's say we have 15 nodes, then we would hash different shards of data out, but it's always going to be sharded across or hashed across 3 of our nodes in our APIC cluster. Okay, so each shard has 1 primary and 2 replicas. And then what's going to happen is essentially each replica is going to use a particular preference. So the writes are always going to happen to the highest preference that happens to be reachable. And if we have a loss of any one node, then that preference 1 or the shard of data would get allocated to another. So let's say we had 5 nodes in a cluster. And any shard, any one subset or slice of data is only hashed or sharded across 3 of the 5 nodes. Well, if we lost one node, then whatever preference value it happened to be would be resharded across one of the other nodes. So let's say it was, this particular shard for policy was sharded across node 1, 2, and 3, and we have 4 and 5 down here with some other shards on them, and we lose node 1. The shard might get pushed out or replicated to either node 4 or 5, but not both. And then whoever owns preference 1 is where the writes are going to happen. Reads can happen from all. And of course, if we lose the node that happens to own the highest preference, there would be a re-election. And we would now have that preference 1 belonging to a new node member. Okay? It's based on a predetermined hash function. It's nothing you can really even get into and change or manipulate. It's just good to know how this happens. Now, you could lose any one node. You could even lose 2 nodes and be fine. So even if, let's say, we had 5 nodes, which I don't have pictured here, we could still lose, let's say, a shard of data is sharded across node 1 and 2, and these 2 nodes happen to be in the same rack and in the same data center. And let's say that corner of the data center has a fire or something catastrophic, and we lose, maybe someone accidentally, carelessly, against policy has water and pours, with the tops of the C220 open, pours it all over. I don't know. We lose the servers. They're, really bad. Well, as long as we still have one node that's active and alive and has a copy of, which it would, that shard of data, it would be replicated out, or at least even if we only had 3, it would still be available. If we had 5, it would be replicated out across the other 2. So it's actually going to be, and this is one of the reasons we do not ever recommend, in fact, we highly advise against putting all 3 APIC controllers in the same rack of equipment. Okay? Don't put them in the same physical part of your data center. And if you have multiple data centers with any sort of stretched cluster across data centers, which we'll talk more about in a future module as very much supported, then we would recommend that one of your APICs be in another data center with maybe a hot standby that we'll talk a little bit more about as well. But it is basically impossible for you to lose all of your data unless you lost all 3 nodes of the APIC cluster at once. So the only way this is going to happen is if you have like a drunken monkey that's running around your data center and replicates itself and pulls all 3, APIC node C220 servers, pours water all over them, happens to know where the shards are. That would be catastrophic. Okay? But other than that, you're not going to run into that issue of losing all of your data. And also, in case of a split brain, automatic reconciliation is performed. So what do we mean by this? Well, this is one of the reasons that we have 3 rather than 2 nodes in the cluster, or even 4 nodes. And actually, I've mentioned that we do support a hot standby. So this would be in the case of, let's say you had a stretched cluster, and I have leaves and spines stretched across 2 different data centers. I would have 2 APIC nodes, let's say 1 and 2, over in data center 1, 1 APIC node, let's say APIC 3, over in data center 2, and then I would have a copy of either 1 or 2 in hot standby. So it would basically be booted and ready to go, but it wouldn't be physically attached to the fabric. And if there was a catastrophic event we actually lost this entire data center 1, we could bring up or just attach the second APIC over at data center 2, have more redundancy. And also, the reason for this is we get into something called the ability to reconcile in terms of who is in charge of rights to the database based on quorum. So it takes a quorum or a majority in order to perform a write to the fabric. So if we did have a split RAID, let's say they're just in 2 different data centers and I have node 1 and 2 over here and node 1 over here. I'm sorry, node 1 and 2 in data center 1, node 3 in data center 2. And we have a loss, a cut of fiber. Actually, let's say, because that could be brought back up, let's say that an earthquake hits and takes out data center 1. Okay? Data center 2 with APIC number 3 is a minority and cannot make any writes or changes to the fabric at all, regardless of how many switches we have. So it takes a majority or a quorum, and if it knows that it was number 3 out of 3, so it knows that there should be 2 other brothers, node 1 and 2, it's not going to allow writes until it sees either node 1 or 2. We can't build a new node 4. So what we would do is that's where we would have that hot standby that was already built, really a cloned copy of APIC 1 over here. And from there, we would go ahead and bring that up, attach it to the fabric because we had a disaster over here, earthquake, the data center's gone. And now we would have a majority. We have number 3 and number 1. So 2 out of 3, we're the majority over at data center 2. And now we would go ahead and be able to perform writes back to the fabric. And then we could add another or recover from backup another APIC controller as node 2. So we're going to talk a lot more about this in a future module, so we'll just briefly give a little bit of airtime to this right now. That ACI really is designed around open APIs and open source code. So everything is accessible, absolutely everything is accessible from the APIC through a RESTful API. So we'll talk a lot more about what is a RESTful API and how to use it in that future module. On top of that, we also have, as another option, a Python native SDK. So it's the only language that there is a native SDK for, but we do have a native SDK. Of course, Python is a snake, so our SDK is called Cobra, right, to go along with our Pythons. So everything is object-oriented. There really is complete comprehensive access to everything in the underlying management information model. There's a consistent naming of objects mapped directly to a URL for that true RESTful API support. We support object, subtree, and even class level queries. We can do RESTful API over HTTP, but of course we would always do it over HTTPS for SSL or TLS 1.2. We would use either a JSON or an XML text file to store our data in, as well as to retrieve data from. And the APIC controllers automatically delegate requests to the corresponding components, so it is unified in that manner. It is transactional in that manner from RESTful APIs, so we can do individual transaction by transaction. It is a single managed entity, meaning we make one call to one APIC. If it's down, we make a call to the next APIC, but we only need to make one call to one APIC to program the entire ACI fabric, whether we have 200 leafs or whether we have 2 leafs. Okay, but they are fully independent components. We have many ACI-enabled fabric devices, such as Microsoft Hyper-V, Open vSwitch, as well as L4 through 7 scripting ability for F5, Avinet, SourceFire, Citrix. Honestly, the list continues to go on and on. Palo Alto, Checkpoint, Fortinet, you name it.